Hello everyone, I am Swaminathan, Assistant Professor, Department of Mathematics, SNS College of Technology. Today we are going to start our session with real life application of vector calculus. This presentation explores the various application of vector calculus, the application of vector calculus to vector and fields, find the real world use in diverse fields like physics, engineering and computer science and electromagnetic fields among the other phenomena. Vector calculus is the powerful tool with many real world uses. Let's derive some key examples. We will start an intro to vector calculus. First, we will see what is vector calculus. The vector calculus is the branch of mathematics concerned with differentiation and integration of vector fields in three-dimensional equilibrium space. The term vector calculus is sometimes used to as a synonyms for the broader subject of multivariable calculus. The concepts includes gradients, divergence, curl, and line integrals. These tools help analyze quantity with both magnitude and directions. Vector provides powerful tool for every variety of applications. We will see the key points of vector calculus. The vector fields, it is assigned a vector to every point in space. For example, wind velocity in the atmosphere, where each point in space has direction and magnitude of the wind. So gradient, it is symbol defined as denoted as del f. It applies to scalar fields like temperature. The gradient points in the direction of the steepest increase. It's a vector. So next we have see the divergence, del dot f and curl. These are the key examples, key points of vector calculus. Next we will see the physics application 1 in physics, that is fluid dynamics. Fluid dynamics uses vector calculus extensively. We can model fluid flow using vector fields. Equation like Navier-Stokes description fluid motion. Next, the characteristic of flow velocity vectors are often used to illustrate fluid motion in application like metrology. Another method for representing fluid motion is a streamline. A streamline represents the path a small volume of fluid flows. The velocity is always tangential to streamline, that is the laminar flow. The diagram first A is shows laminar flow, that is the laminar flow between the pipe and the fluid is high, so known as no slip boundary conditions. The second diagram represents turbulent flow, which streamlines are irregular and change over time. The next application is engineering, that is computer graphics. The computer graphics use vectors to represent vertices, normals, and lighting directions. Operations like transforms matrices enable rotation. How is vector visualized? The standard number or components of a vectors. Next we have to see machine learning. So how the vector calculus plays crucial role in machine learning, particularly in optimizing algorithm and understanding data representation. So the standard numbers are components of vector. The components show influence in the given direction of the vector. So it signifies the position of a coordinate in an n-dimensional space. Next we will see the meteorology. So the for weather forecasting, in predicting the weather with vectors. In modern meteorology, vector concepts are instrumental in modeling wind patterns and storm paths by representing with wind speed and direction as vectors. Next, we will see the robotics. Calculus is basically mathematics of changes. In robotics, specifically motion, the mobile robotics drive around with a velocity, with a velocity, with a velocity and direction of the vectors. Next, we see the conclusion, the power and versatility of the vectors. The vector calculus is an indispensable tool across the various fields. Its application spans from physics to engineering and beyond. The ability to model, analyze the vector fields is crucial. It derives innovation in many areas of science and technology. Its versatility makes it is an essential tool. So it is the few applications of vector calculus. We will see the brief application and the problems in next video. Thank you.